So today we're going to cover Chapter 1, Section 5A. Today we're going to learn about complex numbers. The first thing that you need to do in order to work with complex numbers is you need to memorize that I is equivalent to the square root of -1 and that I squared equals -1. So whenever we are going to be adding, subtracting, or multiplying, we're just going to treat I as if it's a variable. Now, when your answer, though, includes, and let me fix this should be an exponent, so it's really I to the second. So whenever your answer includes an I squared or an I to the second power, we're going to replace I squared with a -1, because this is what you're going to memorize, that I squared equals -1. The standard form of an answer, when it's written in standard form, is going to have A plus BI, where A is going to be the real part, and the BI, this is going to be the imaginary part of the answer. So it'll have an I next to a number. Now, this first example wants us to rewrite this expression in standard form. Now, you don't know how to square root a negative number, so I'm going to show you all you need to do. So whenever you have the square root of a negative number, we're going to do a factor tree. Now, if this helps you at the beginning to first break it down to 25 times -1, and then from there, you break down the positive square root like normal. Square root of 25 is 5. And then now, up at the top, remember I told you to memorize that the square root of -1 is an I. So that's all we need to do when it's a negative number, is what's going to come out of that square root is the letter I, and then you break down the radical like normal. So here, this final answer is just going to be 2 plus 5I. Now, technically, it wouldn't have mattered if I would have done the -1 first and put -1 times 25 and then gotten I and then the 5. It doesn't matter because multiplication is commutative, but technically a lot of times they're going to put the I after the number. So let me show you another example. Let's say I gave you -4 and I ask you to simplify that. Again, you could break it down if it helps you to see the number times -1 first, and then you square root the 4, and then square root the -1. Okay, so for this first one, all they want me to do is simplify and write the answer in standard form. So I need to put the real part first, and that's going to be adding the numbers that don't have an I, and then adding the two numbers that have an I, and put those second. And again, it's just like I'm combining like terms. So I'm going to add my two real parts first. So 4 plus 1, I get 5. And then now I'm going to go back and add my imaginary parts. 7I plus -6I is just positive 1I. And now my answer is in standard form. So essentially, when I'm adding numbers that have imaginary, all I'm going to go ahead and do is just add like terms. Let's try the next one. I'm going to add my reals. So 1 plus 3. And then I'm going to add my imaginaries. 2 plus -2. This gives me a 0I. I don't need to put in the 0I. I can just put my final answer as positive 4. But recognize if maybe on a standardized test, an SAT or PSAT, that they put it in there as a 0I. But just remember, when you're combining your like terms here, if you end up with a 0, you don't need to write it. Let's try the next one. All I'm really doing here is combining like terms. I need to distribute the subtraction sign into each of the parentheses. So the first term, the 3I, stays the same. Then I'm going to distribute -1. I could think of this as a -1 times -2 becomes positive 2, or do a keep, change, flip, whatever's best for you. And then here, -3I distribute this subtraction sign. So negative 2i minus 5i. Now I can go back and combine my like terms. I'm going to combine my reals. So my reals are positive 2 minus 2. Again, I got a 0 here. And then now combine my imaginaries. Positive 3 minus 3 is 0. Minus 5i is negative 5i. So my final answer here is just negative 5i. The next one is exactly the same thing. I'm just going to distribute and then combine like terms. So I'll distribute the negative sign only on this last one. So everything else just gets rewritten. So 3 plus 2i plus 4 minus I minus 7 minus I. Let me go back, add all my reals. 3 plus 4 is 7. Minus 7 is 0. Then add my imaginaries. 2 minus 1i is 1i. Minus 1i is 0i. So this final answer is just 0. For number 5, whenever I'm multiplying with imaginaries, again, just treat it as if I is a variable. And I'm just going to distribute. So I'm going to distribute the 4 to the negative 2. This will give me negative 8. And then distribute the 4 to the 3i. And this gives me 12i. And I'm done. And it's in standard form. I have the real part and then the imaginary. So for number 6, we have two binomials that they're asking us to multiply. And all I'm going to do is FOIL. So I'm going to go ahead and multiply or distribute, however you want to think of it. So I'm going to multiply the 2 times the 4. I get 8. Then I'm going to distribute the 2 or do the outer to the last one. Gives me 6i. Then I'll do the inside. Negative I times positive 4. Negative 4i. And now finally the last, negative 3i squared. Now remember, whenever you end up with an I squared, we need to replace it with a negative 1. Because remember from the beginning, I told you that I squared equals negative 1. So I'm going to replace this I squared with a negative 1. I'm going to also combine my middle terms here. Positive 6i minus 4i. And this is going to give me 2i. And then I still have that 8 in the front. I'm going to multiply the negative 3 and the negative 1. This will give me positive 3. Still have the 8 and the 2i here. And now I still have to combine my reals. And this will give me 11 plus 2i. And again, you put the imaginary second and the real first. Try the next one. Same thing, we're just FOILing here. So I'm going to do first, 3 times 3 is 9. I'm going to do the outside. 3 times negative 2i is negative 6i. I'm going to do the inside, positive 6i. And then finally last, positive 2i times negative 2i is negative 4i squared. I again ended up with a I squared in my problem. So again, I'm going to replace that with a negative 1. Notice this time my middle terms canceled out. I still have the 9. And now I'm going to multiply the purple. So 9 and then negative 4 times negative 1 is positive 4. So my final answer here is 13. Now, this is an example of multiplying by the complex conjugate. Remember, we did this when we tried to get rid of square roots. This is how we're going to get rid of an I in our problem. So this is multiplying by the conjugate, And whenever we do that, the I disappears. Let's try number 8. Remember, when it's a binomial squared, you can't just put the 2, that exponent of 2 on the 3 and on the 2i. Remember, the easiest way to do this is to write it twice and FOIL it. So again, I'm going to multiply first. 3 times 3 is 9. Then I'm going to do the outside. 3 times positive 2i is 6i. Then the inside. 2i times 3 is positive 6i. And then finally, last, 2i times 2i is 4i squared. This time my middle does not disappear. So I'm going to go ahead and add the middle and change that I squared to a -1. So when I add the middle, I get positive 12i. I now need to multiply the purple. So the 9 stays, the 12i stays, and then positive 4 times -1 is -4. I now can add my 2 real pieces. 9 minus 4 is 5, plus the imaginary 12i. So again, I'm going to do first, 2 times 3 is 6. Then I'll do the outer, or distribute the 2 to the positive 3i, which gives me 6i. Then I'm going to do the inside. -4i times positive 3 is -12i. And then finally, last, -12i squared. Again, you're going to combine the middles and also replace the I squared with a -1. The middle terms become a -6i, and I have the positive 6 at the beginning. I need to multiply the purple. Becomes a positive 12. Still have the 6 and the imaginary. And now add your reals. 6 plus 12 is 18. And then put in the imaginary. All right, so for the next one, this is an example of multiplying by a complex conjugate. So the complex conjugate is going to have the same number, but the imaginary part is going to be the opposite sign. So just like we did with the radicals, remember we made the radical the opposite sign. The purpose or the reason why we do this is to make the I disappear. So when you multiply by the conjugate, the I will disappear. So just like with square roots, we can never leave a square root or a radical in the bottom of a fraction. We can never leave an I in the bottom of a fraction. Remember when we did it with the radicals, the shortcut was just to do first and last. I can do the same thing here. The middle terms are going to cancel out. Now, in the homework, you may get questions where all they ask you to do is identify the complex conjugate. And all you have to do is make the I opposite. So here, this one wants me to actually multiply by it. So I'm going to rewrite the first, or the original. And my complex conjugate is just making the I opposite sign. So that would be the conjugate, complex conjugate. And now I FOIL it. And watch what's going to happen. My I is going to disappear after I multiply this. So first is 1 times 1 is 1. Then the outside, 1 times -I is -I. The inside, positive I times 1 is positive I. And then finally, last, -I squared. So again, notice the inside, or this middle, cancels out. I still have the 1. I'm also going to replace the I squared with a -1. But notice I kept the subtraction sign here, and then this negative turns into 1 plus 1, and then the final answer is just 2. So shortcut, whenever you're multiplying by the conjugate, you can just do first and last. essentially it becomes a squared plus b squared. Let's try the next one. I'm going to rewrite the original. The complex conjugate, same numbers, but opposite sign. And now if you just want to do first and last as a shortcut, this would be the shortcut. Do first, you get 16. Do last, you get negative 9i squared, but then the I squared becomes negative 1. So essentially it's becoming 16 plus 9. So then this becomes 16 plus 9, and you get 25. Remember, if you do the whole FOIL, the outer and the inner are going to cancel out when it's the conjugate. So the next one is dividing with complex numbers. So remember, your denominators must be rationalized. In other words, we can never ever leave an I in the bottom of a fraction, never an I in the denominator. To rationalize, we're just going to multiply by the complex conjugate, which makes that I disappear. So here, I want to rationalize this. I need to make that I disappear. And remember, whatever you multiply to the denominator, you also have to multiply to the numerator, just like before with the square roots. So I'm going to be multiplying the numerator and the denominator by the complex conjugate. I need to distribute to the numerator. So 4 times 1 is 4. 4 times I is 4i. Now for the denominator, I could go ahead and do the whole FOIL process. I'll go ahead and show it to you. But again, remember, whenever you're rationalizing, the shortcut is just to do first and last. But let me do the whole FOIL. So first would give me 1. Outside would give me positive I. Inside gives me negative I. And then finally last, minus I squared. So notice the middles. When you combine the outer and the inner, it cancels. And then now I have 1 minus, and then replace the I squared with negative 1, which turns into 1 plus 1. So my denominator is 2. So the numerator is the 4 plus 4i, and then the denominator is 2. Now, when we go to simplify these, this denominator must be able to simplify with both the real and the imaginary. And it can. I can divide all 3 of these numbers by 2. So once I do that, this 2 becomes a 1, the 4 becomes a 2, and this 4 becomes a 2. So my final answer is 2 plus 2i. Okay, so for the next one, again, we need to rationalize. We can't leave that I in the denominator. So I'm going to multiply the numerator and the denominator by the conjugate. And the conjugate, remember, is the opposite sign. So 1 minus I to both the top and the bottom. I need to FOIL the top. The bottom I could get away with just doing first and last. I know on the previous one I did the whole FOIL, but you don't have to. But remember, always that numerator, you need to FOIL it. So first gives me 1 times 1 is 1. Then the outer gives me negative I. The inside gives me negative I. And then finally, the last gives me negative I squared. Now for my denominator, I can just do first and last. So if I just do first. All right, so this last one is positive I squared. Thank you. Good catch. All right, and then here, let me go ahead and just simplify this top. This does not cancel. This becomes 1 minus 2i. And then the purple becomes plus negative 1, or just minus 1. Let me go ahead and do the bottom. I'm running out of room here. So then for the bottom, if I do first, 1 times 1, and then if I just do last, it's negative I squared. So this becomes 1 minus negative 1. So now I end up with, in the numerator, this 1 plus negative 1 is gone. So I'm only left with the negative 2i in the top. And then the denominator, this 1 plus 1, that's what it becomes. So that's a 2. And then notice I could simplify, and these would become 1s. So now I'm just left with negative I.